In this video, I'm going to be explaining the process of neuron communication. So, the neuron system communicates through an electrochemical process which sends signals electrically through the neurons. Then the axon stays in resting potential, which is when the inner part of the neuron has more negatively charged ions than outside of the cell. But when part of the axon closest to the cell body is stimulated by an electrical signal, it all changes. First, for the signal to even pass through the axons, it has to be strong enough to pass the threshold or certain level of strength. So once the electrical signal reaches threshold, positive sodium ions are allowed to enter the neuron and change from a negatively charged axon to a positively charged axon because of the new sodium ions is called depolarization. So when the cell is depolarized, it has more positive ions than negative, action potential occurs, and once it starts, it cannot be stopped, so the chemical signal travels through the axons toward the axon terminal buds. During exocytosis, the vesicles of the neuron release neurotransmitters into the synaptic gap, and there they may connect to the receptor channels of the next neuron. But not all the neurotransmitters are accepted by the next neuron. So through the process of reuptake, they are reabsorbed into the terminal buds. So before an axon can fire again, it has to return its resting potential during a brief time called the refractory period. In other words, it is recharging. The axon itself is recharging itself to prepare itself for more ions to be positively charged. Thank you.